You know, we always dream of reaching for the stars, but what actually happens when we get there? Humanity is pushing deeper into space than ever before, which is amazing. But let's be real, our solar system is not exactly a welcoming place. So think of this as a tour of survival. And our first stop is pretty much the most unforgiving planet you can possibly imagine. So here's the ultimate test. Forget Mars for a second. Let's talk about Venus. How long could we, with all of our amazing technology, actually last on Earth's so-called sister planet? Well, the answer is both complicated and absolutely terrifying. First up, there's the heat. And this is it's mind-boggling. The surface of Venus is a staggering 470 degrees Celsius. No, that is not an exaggeration. It is literally hot enough to melt lead. Your oven at home doesn't even come close. And the worst part? The heat is so intense and so uniform that even the night side offers zero escape. Okay, so let's say somehow you survive the heat. Well, then the pressure gets you. The atmosphere is 90 times denser than Earth's. To put that in perspective, that's like being 3,000 feet, or nearly a kilometer, deep in the ocean. This pressure would instantly crush a military-grade submarine like a soda can. Your body, it wouldn't stand a chance. And believe it or not, we have tried to conquer this place. This right here is Venera 13, a Soviet probe that was built like an absolute tank. It was designed to withstand almost anything, and it actually managed to land on Venus and send back data for just over 2 hours. Then the planet's hellish conditions completely obliterated it. The toughest machine humanity has ever sent was utterly defeated. So what is this stuff you'd even be standing in? It's not really air. The insane pressure and heat force the carbon dioxide into this bizarre state called supercritical CO2. It's weird. It flows kind of like a liquid, but it fills space like a gas. It's this dense, corrosive, soupy medium that would dissolve and destroy anything organic in an instant. So, what does this all mean for a person? Look, even in some theoretical, futuristic suit made of titanium with advanced cooling, your systems would fail. You might last 20 minutes before you're just cooked alive. But in a standard NASA suit like we use today, you'd have less than a minute. Game over. As deadly as Venus is, and it's pretty deadly, it's not the only death trap in our solar system. The tour of fatal worlds continues. Next stop, Mercury. Mercury has basically no atmosphere to trap heat, which creates the most extreme temperature swings you can find. On the sunny side, you're flash fried at over 400 degrees Celsius. On the dark side, you're flash frozen at minus 173. There is absolutely no in-between. So, what's your total survival time?